This is the Number Sense Intermediate Open House. I'd like to thank everyone for coming out here today, like spending your time listening to me talk about number sense tricks. So I'm Justin Lai. For those of you that don't know me, I've been doing number sense math contests for a long time, like since elementary school. I've won a lot of awards in like competitions like TMSCA, UIL, Math Counts, Mathleague.org, and I have my fair share of medals in like number sense meets, I guess, as well. For example, I won like third place on the number sense state meet for high school. So in my free time, I like mainly like to hang out with my friends, I guess listen to music. First, can everyone turn their cameras on for me? That's like a thing in this class, just to make sure that everyone's, like paying attention, or like it's 12 weeks from September 10th to December 3rd, and there's going to be no class on Thanksgiving, like Thanksgiving weekend. So no class November 26th. So the class is from 2 to 3:15 p.m. Central Time every Sunday. So basically how class will go is I'll teach for maybe like 40 or 45 minutes. I'll give you guys like a 5 to 10 minute break, and then we'll go back to class. So in every class, you can see here that we'll cover a couple topics. So like maybe three or like two to three tricks or topics every week. And like the goal of this class is just to learn more in depth about like the harder questions about number sense. So hopefully like, oh, and if you guys don't know what number sense is, it's just like basically a test of your mental math abilities without like any paper or calculators. So it's a combination of knowing the right tricks to use on questions, and also a trick, and also how fast you can do these questions, maybe with tricks or without tricks. But in general, even if you don't want to compete in the contest, it will still help your mental math skills. It'll still help you like be faster and more accurate in just general math everywhere else. So I think that's the cool part about number sense. And yeah, this is basically the same thing. And hopefully, if you're taking the intermediate class, you should already have some basic like number sense knowledge. So you should probably know the basic tricks. Like I would say Lee off maybe times 25. Like just all the basic number sense tricks, I think you should probably have for this class. So here are the various places where you can take like the number sense test. So we have TMSEA, which is in Texas elementary and middle schools. There's UIL for high schoolers in Texas want to do number sense. And there's mathleague.org for elementary schoolers. So how many have you guys have heard of like any of these contests or even participated in them? You can just like use the raise hand feature. Okay. So some people, yeah, a lot of people actually. So that's good to hear. Yeah. So hopefully this class will help you get better at number sense for these concepts. So in this class, we'll go over the tricks, like we'll go over tricks in class. We'll also play Kahoots in class after we cover every trick to make sure you guys get a good review. And then we'll also give you guys homework for outside of class. So here it says like 2 hours per week, but in reality, it shouldn't really take you guys 2 hours like every week to be completing the homework, because as you get faster at number sense, it should take you like less time to do the homework. So that's kind of like a reward of doing the home of getting better at number sense. Maybe it'll take you some less time to do homework. The homework will always be in form of like these worksheets. They'll always be posted on Canvas for you guys to see and do. All right, so now let's get into like an example of a trick that we would cover in class. So today we're going to be covering advanced sequences and series, and I think it will be how to add up the sum of the terms of an arithmetic series. So first, does anyone not know what an arithmetic sequence or series is? Like please like in this class in general, please be free to ask questions. Like there's no reason that you guys shouldn't be asking questions about things that you don't know. Please never feel ashamed to ask any questions. It's like a natural process of learning math. If you have any question, you can either raise your hand, like, or unmute and ask, or you can just send me a private message and I won't say your name if you want to be more anonymous, and then I'll answer the question. So does anyone not know what an arithmetic series or sequence is? Okay. I'm assuming that everyone knows, so we can move on. So for example, we have the arithmetic sequence 32, 36, 40, dot, dot, dot to 52, and we want to find the sum of this sequence. So here, if in general, we can label the terms of an arithmetic sequence A1, A2, A3, A sub n, where A1 is always going to be the first term in the series, and A sub n is going to be the last term in the series. And any number in between, say A sub 2, this number represents which term it is in the sequence. So this is A sub 2 because it's the first, and this is the second term in the series, which is why it's called A sub 2. And then we can call the sum of the series S of n because S stands for sum. So it's a sum of n terms of an arithmetic sequence. And then n is just how many terms there are total. So the formula for finding the sum of the first n terms of an arithmetic sequence is this formula right here. So in I guess less mathematical speak, we can say that the sum S of n is equal to the number of terms in the series multiplied by the average of the first and the last term. So does anyone have like a question about this definition? Because we can just break each term down. S of n stands for the sum of the sequence. N stands for the number of terms in the sequence. A sub 1 and A sub n are the first and the last terms in the sequence respectively. And if we divide by 2, we're finding the average of the first and the last two terms. So does anyone have a problem with this definition? Okay. And we can see here that it's defined here as well. And then in general, to find A sub n or A sub 1, we can use the formula that the last term in the sequence is equal to the first term in the sequence plus the number of terms minus 1 times d, in which d is the common difference of the arithmetic sequence. So we can see here, like in our problem, that the common difference is 4 because every time the term increases by 4. So from 32 to 36, we have an increase of 4. 36 to 40, increase of 4. And if we continue going on, then our difference, or D for short, be equal to 4. So now let's look at a short proof of it. So we'll start with the common statement here. We know that obviously the sum of two terms, this the sum of an arithmetic sequence plus the sum of an arithmetic sequence is equal to 2 times the sum of an arithmetic sequence. That's just logically how it works. So then we can write that the sum of the first arithmetic sequence in this column is equal to the first term in the sequence plus the second term plus the third term all the way to the second to last term plus the last term. Because again, if you look at the definition of how we defined it, the last term in the sequence is equal to a1 plus n minus 1 times d. Here, the last term in the sequence is equal to a1 plus n minus 1 times d. The first term in the sequence is a times 1. The second term in the sequence is equal to the first term in the sequence plus the common difference. So see here, the second term, 36, is equal to the first term, 32, plus the common difference, which is 4. So here we have the first term, the second term, the third term, and so on to the fourth term and the fifth term. And now, in this column, it's the same thing, except we start from the bottom. So we have the first term down here, the second term down here, third to last term, second to last term, last term. So does anyone have a question about how they structured writing the sum of the sequences? Okay, no? Okay. So now what they did is they added the rows. So if we see here, if we add these two numbers together, we get a1 plus n1 minus 1 times d. So that equals 2a1 plus n minus 1 times d. Again, if we sum this row with this row, get a1 plus d plus a1 plus n minus 2 times d, which is equal to 2a1 plus n minus 1 times d. And the same thing goes for the whole thing. If we keep going down, we'll see that if we keep adding the rows, we always get the same number here, which is 2a1 plus n minus 1 times d. So if we add all these rows up, we should get a number that's equal to 2 times the sum of the series. So here, this is written out for us. 2 times s of n, which is this number up here, is equal to the number of rows n times the value in each row, which is 2 times a1 plus n minus 1 times d. But now, if we look at here, we can actually see that a1 plus n minus 1 times d is equal to an, which we defined earlier over here. So if we know that a1 plus n minus 1 times d is equal to an, we can just rewrite this as 2sn equals n times a1 plus an. So if we divide both sides by 2, we get sn equals n times a1 plus an over 2. So does anyone have a question over this proof? Again, like, you can either unmute or just private message me if you have any questions at all. Okay, if there are no questions, we'll go straight to an example of how you actually apply this. So let's look at the sequence we had earlier. So first, when you look at arithmetic sequence, you should determine a couple of things that you need for the formula. The formula is equal to Sn equals n times a1 plus an over 2. So how do we find each of these things? Usually, we know a1 is the first term in the sequence and an is the last. So we already know that a1 is 32, an is 52. So now, in order to find n, we should find d. So in this case, d is just the common difference. So again, we know that the common difference is 4 because every time the values in the sequence are increasing by 4. So we can say that d equals to 4. So now, in order to find the number of terms in the sequence n, we have a formula again, where n is equal to the last term minus the first term over the common difference plus 1. So here, in this example, we have the last term equals 52. The first term is 32. The common difference is 4. And then we add 1 at the end. So we have 20 over 4 plus 1, which is 6. So we know that we have 6 terms in our sequence. So now we have everything that we need to plug back into this equation. So we have S equals the number of terms, which we just found was 6, times the first term plus the last term divided by 2. So if we do 6 divided by 2, that's 3. Then if we have 32 times 52, we have 84. So we know that 3 times 84 is 252. So we can say that the sum of this series is 252. Does anyone have a question over this example? Like, I know it seems like kind of complicated here, but trust me, like, if you actually try the question with real numbers, it'll make a lot more sense. But again, if you have questions now, just feel free to ask. Okay, if no one has questions, we'll go on to these. So I'll do the first one with you guys, and then I'll see if you guys want to do the rest by yourselves or if you want me to do them. Okay, let's look at 2 plus 7 plus 12 plus 20, all the way to 22. So again, let's define some things. A1. Can someone tell me what A1 is in the first sequence? Yeah, Rex. Can you say that again? Yeah, it's 2. Can someone tell me what AN is in first question? Yeah, Rex. Yeah, it's 22. So again, remember our formula is that S equals the number of terms times A1 plus AN over 2. So now we have A1 and AN. So all we need to find is N. But remember again that N is the last term minus the first term divided by the common difference plus 1. So in order to find the number of terms, we have to find the common difference first. So we can see that in this sequence, the common difference or the values of the term are always increasing by 5. From 2 to 7 is 5, 7 to 12 is 5, and so on. So we can say that D equals 5. So now to find N, we can just do N equals the last term, 22, minus the first term, 2, divided by the common difference, 5, and plus 1. So we can say that N equals 5. Okay, so now, yeah, so we know that there's 5 terms in the sequence. So now we have everything we need to plug in into this S equals N times A1 plus AN over 2. So let's do it. S equals number of terms, 5, times first term, 2, plus last term, 22, divided by 2. So we have 5 times 24 over 2, which is just 60. Does anyone have a question over how we got to this answer of 60? Oh, sorry. Okay. So another trick that you can do to find the number of terms, instead of memorizing this equation, what you can just do is you take this last term, subtract it by the first term. So we know that 22 minus 2 is 20. Find the common difference, which is 5, and then just add 1. So you don't actually have to go through the process again. You can just do it quickly, like using the sequence. So we can quickly find out there's 5 terms. Okay, so I'll do one more example and then I'll leave you guys to the rest. Okay, leave that up. Okay, so let's look at number 2. So I'll go slightly faster this time because I think that we should be able to do it faster. So again, first term, A1 is 1. Last term, that's AN. AN equals 29. Now to find number of terms, we can do the last term, 29, minus the first term, 1, divided by the common difference. So the common difference in this one is we can just see from 1 to 5, that's 4. 5 to 9, it's also 4. That means that our common difference is 4. So that means it's last term minus first term divided by common difference plus 1. So that's 28 over 4 plus 1, which is 8. So we know that there's 8 terms in our sequence. So now we can just plug directly into our sum equation. Sum equals number of terms, 8, times first term, 1, plus last term, 29, divided by 2. So if we do 8 divided by 2, that's 4 times 30. So that's 120. Okay, does anyone have a question over how we did this? Okay, if there's no questions, um, do you guys want to do 3, 4, and 5 by yourself, or do you guys want me to do them for you? You can type in the chat or say if you guys want to do it by yourself or just chat. By yourselves? Okay. Um, I'll give you guys until 2:27, I guess, to do these questions. And if you have an answer, please private message me the answer that you think you got. And then we'll see. We'll check back in 3 minutes. Okay, I'll do number 3 now. You can keep working if you're so busy, but let's go through this. So again, we define 30 as A1 because it's our first term, 66 as AN because it's our last term. Um, okay. Okay. Okay, so now let's find the number of terms. The number of terms is 66, our last term, minus our first term, 30, divided by the common difference. So the common difference in this question, if we look, it's increasing by 4 every time. So our common difference is 66 minus 30 divided by 4 plus 1. So 66 minus 30 is 36. So 36 divided by 4 is 9. So so it's 9 plus 1, which is 10. But now we plug it in into this equation up here, which is that the sum equals the number of terms times A1 plus AN over 2. So the sum is equal to the number of terms, which we just found to be 10, times the first term, 30, plus the last term, 66, divided by 2. So this is 5 times 30 plus 66 is 96. So 5 times 96 go to 480. Okay, let's go on to number 4 now. 17 plus 20 plus 23 all the way to 41. First term, A1 is 17. The last term, 41, we can call A sub n. To find the number of terms, again, last term, 41, minus first term, 17, divided by the common difference, which in this case, 17 to 20 is 3. 20 to 23 is also 3. So it's 41 minus 17 divided by 3 plus 1. So this is equal to 24 over 3 plus 1, or 9. So now if we plug it back into this equation up here, we have sum equals number of terms times first term plus last term divided by 2. So this is 9 times 58 over 2, or 261. Okay, now for the last question, it's the same thing. First term, 49, A1. Last term, AN, 99. The number of terms is last term minus first term divided by common difference. So common difference, 49 to 54 is 5. 54 to 59 is also 5. So common difference is 5. Then plus 1. So this is 50 over 5 plus 1, which is 11. So that means that our sum, again, is number of terms, 11, times first term plus last term divided by 2. So if we evaluate this, we get 814. Okay, so the main takeaway from this is you first define what your first and last term are. Then the next step is find the number of terms. It's the last number minus the first number divided by the common difference plus 1. And then we use the formula up here. The sum of the series is equal to the number of terms in the series times the first term plus the last term divided by 2. All right. So now I think we'll play a Kahoot over the sum of sequences and series. So basically in this class, every time after we learn a new trick, we'll always play a Kahoot to make sure to check our knowledge, or play. Yeah, just check our knowledge, see who can. It's like a friendly competition on who can do it fastest. So if everyone can please like join the Kahoot at www.kahoot.it, and the game pin is 342602.
Can we see the questions on our phone screens, or do we have to split screen?
I'm not sure, but I'm pretty sure. Can you just check on the first question? I think Kahoot had like a new update where you should be able to see it on your screen, but if you can't, then just split screen. Give everyone else like a minute to join, and I'll start. Okay. I'll be starting now if no one has any objections.
No, I'm almost.
Okay, I'll wait then. Okay, is everyone in that wants to play? If not, I'll be starting soon. Okay, I'll be starting.
What are we supposed to find?
The sum of the sequence or series.
Um,
Okay, so the correct answer was 392. Okay, I'll explain this one because only one person got it. So the question was 35 plus 39 plus 43 to 63. Okay, so again, let's find the first term and the last term. So the first term is 35, the last term is 63. So now we need to find the number of terms in the sequence. Remember, the number of terms is the last term minus the first term divided by the common difference plus 1. So now we have everything that we need. So the last term is 63, first term is 35. Can someone tell me what the common difference is? Just unmute or say in chat.
4.
Yeah, it's 4. Because look, from 35 to 39, that's 4. 39 to 43, that's 4. Its common difference is 4, then plus 1. So 63 minus 35 is 28. 28 divided by 4 plus 1 is simply 8. So now remember our formula for sum. Sum is equal to number of terms times first term plus last term divided by 2. So we have number of terms, which we just found was 8 times first term, 35, plus last term, 63, divided by 2. So this is 4 times 98, which is 392. Does everyone see how the answer is 392 now? Or does anyone have any questions still? Or are we all good?
Wait, so the sum is minus over d plus 1, or is the sum
The
plus
number of terms is an minus a1 over d plus 1. But the actual sum is n times a1 plus an over 2.
Wait, so am I supposed to type both the sum and the
No, only type the sum, the second
okay.
number. We only want to find n so we can use it for the sum.
Okay.
Okay. Does that make sense for everyone? Or is that
Yes,
too confusing?
it makes sense.
Okay. Next time for the next question, I'll write both these formulas somewhere so that everyone can use them. Um, okay. Okay. So now you guys can use this for the next question. Yeah, sorry about this one. This one's like a little more tricky because it involves like negative numbers. So if we look at the question, uh, so it's from negative 37 to negative 22. So, uh, can we have more time? Let me see if I can change that in the setting. But I'm not sure if I can actually change. Is there any way like I can pause it or yeah, I'm not sure how to give you guys more time.
The game is paused.
Oh, it is?
It is.
Okay,
It says look up game is paused.
okay. Wait. Okay, I'll look on the next question. But I'll explain this one first because it's more tricky. So in this question, we had negative numbers. So the thing about negative numbers is there's like two ways to approach it. You can either okay, let's just use the formulas. So even though it's negative numbers, the same concepts still apply. The first number, negative 37, is A1. The last number, negative 22, is A sub n. So let's look at
Well, I have a
finding,
question.
yeah.
If you add negative 37 and negative 22, you can't divide it over 2.
I think you can because you can still divide negative numbers by positive numbers,
Yeah, but
right?
how do you divide negative 59? It's not divisible by 2.
Oh, it's because okay, let me show you. Okay, so an is equal to negative 22 minus a1. But the thing about a1 is that a1 is actually negative 37 itself. So these two negatives cancel out and become a positive. So it would actually be negative 22 plus 37 on top. But then it's also not divided by 2, right? Because the common difference in this question isn't 2. From negative 37 to negative 32, we actually have a 5 like increase. From negative 32 to negative 27, we have another 5 increase. So that means that our common difference is 5. So if we do this plus 1, we have negative 22 plus 37 divided by 5 plus 1. So this becomes 4. So that means that we have 4 terms in our sequence. So now to actually find S, we have N, which is 4, times A1, which is negative 37, plus A2, which is negative 22, divided by 2. So if we do 4 divided by 2 first, we get 2, and then times negative 37 minus 22, which is negative 118. Does that make sense for everyone? Or is that, does anyone have any questions? Yeah, I'm sorry it had negative numbers, but the concept still applies. So I think we'll do one last question and then that'll be it. Okay. I'll see if I can try to pause it to give you guys more time for the next one. Okay. Yeah, wait. Yeah, I don't think I can pause it. Sorry.
Why is the number negative?
Excuse me?
If A, oh,
Okay, so this one was better. Do people want explanations or are we okay on this one? Like again, like if you need an explanation, like you can ask. If not, I'll be going back to the PowerPoint. Okay. It seems that no one has questions on this one. But again, it's the same concept. I can go over it really quickly. The last term is AN. So the last term is 23. First term is negative 17. To find the number of terms, it's the last term, 23, minus the first term, which is negative 17. So it's 23 minus negative 17. So it would actually be just 23 plus 17, which is 40, divided by the common difference, which we can see here. Every time it's increasing by 5. So it will be 40 divided by 5, which is 8, then plus 1. So we know that we have 9 terms. Then we do number of terms, 9 times first term plus last term divided by 2. So negative 17 plus 23 is 6. Divided by 2 is 3 times number of terms, which is 9. So it's 27. Okay, so I think that's it for the Kahoot. Congratulations to Timothy, Ellie, Rex, Big Brian girl and Yo-Yo for participating in the Kahoot. But yeah, so we're near the end of the open house. Again, like, thank you all for coming out here today. I hope that you guys all sign up for this class. You guys all seem like really smart kids that want to learn a lot more about number sense. I can see that you guys have a lot of potential to be fast at math and do good in number sense. Again, you can find this class on the Momentum Learning website under 2023 fall online in school math, and then you can click on number sense intermediate for more details if you want to see more. But again, if you need to contact Momentum Learning, find them on the website at momentumlearning.org, or you can call them at their office phone or even email them at the email provided. But then again, thank you guys. Like, seriously, thank you for all coming out here on like a Sunday afternoon to listen to me talk about number sense.